Lesson 1.14, trig limits part 2. We're going to talk about the two other types of trig limits you might see, and this first type is going to be a combination of the two identities we learned. Sine of x over x is going to equal 1, and 1 minus cosine of x over x equals 0 as they both approach 0. Real quick, I want to talk again about what happens if I see limits of the reciprocal of these. And remember, reciprocal is flipping a fraction. So let's say I have x over sine of x. What does that equal? Well, I graphed it. I wanted to show you if this can show up. This on my iPad. Okay, so that's this one. As x approaches 0, our limit would equal 1. So we'll put 1 on that one. Okay, and then on this one, if I had x over 1 minus cosine of x, the reciprocal. I'll show you what it looks like on the graph. So I'm going to turn off the red one, and then that would be the blue. When x approaches 0, we have a vertical asymptote here, so that does not exist. And so I just wanted to clarify on those, and those would be a good thing to add to your notes. Also think about it this way. If our limit is 1 for this identity, then the reciprocal of it is going to be the reciprocal of 1, which is still 1 over 1 or 1. But if I have something that equals 0, that's 0 over 1, let's say, and I flip it, I get 1 over 0, and that does not exist. So maybe think of it that way, and that'll help you remember. Okay? All right, so number 1. We've got 5x minus 5x cosine of x in the numerator. I see a GCF of 5x. I'm going to take that out. And so we'll have 5x times 1 minus cosine of x over 4x sine of x. I'm going to pull out this this fraction of 5/4 to have times the limit of x times 1 minus cosine of x over x sine of x. Okay, so what's happening is we have both of these identities here. I have 1 minus cosine of x over x, and then I'm going to have x over sine of x, which is the reciprocal one I just talked about. So let's split them up to have 5/4 times the limit as x approaches 0 of, I'm going to do 1 minus cosine of x over x first. So that uses those pieces, and then I'll have times the limit as x approaches 0 of x over sine of x. I'm running out of room. Okay, and then we talked about this is going to equal 0, and then this would equal 1, but it doesn't matter because it multiplies to make 0. Right, number 2, we have 3 terms in the numerator, all over 7x. The good thing is I like that I'm seeing 1 minus cosine of x over x. So this is one where, because we have addition and subtraction in the top, we're going to split it up into 2 fractions, and we're going to have to keep that common denominator. So I have the limit as x approaches 0 of, I'm going to put the 1 minus cosine of x first over, I have to keep it 7x. But in this case, now I'm going to have to go minus, because this has a leading coefficient of a negative. So minus the limit as x approaches 0 of, or I guess you could do plus a negative. Maybe I'll do that. Plus a negative 10 sine of x over 7x. Okay, so again, imagine adding these fractions, ignore the limit pieces. I would end up back with what I started with. Okay, and then I want to take out the 7, so I'll take out a 1/7 times the limit as x approaches 0 of 1 minus cosine of x over x, plus I'll take out the negative 10/7, so that's where you could have had a minus here instead, times the limit as x approaches 0 of sine of x over x. So this is 0, so 1/7 times 0 plus negative 10/7 times sine of x over x is 1. So then that would be nothing, and then that would be a negative 10/7. So some of these you will get some weird fractions. Top of the next page, I want you to pause and see if you can figure this one out. You could have, or you should have, factored out the 10x first. That leaves you with a 1 minus cosine of x, so I'm seeing an identity that I need. So I put that first. I could have went on and taken out a 10 here, but I didn't, so if you did, that's fine. And then times limit of 10x over sine of x. And so there's another identity that I needed. And so I split it up to where I just kept this the same, which I know that's going to be 0, and then I pulled out the 10, so times 10, and then this identity is 1, but you multiply and you get 0. Right, and the last type is trig identities. One trig identity you need to remember is the Pythagorean identity. And that one was that sine squared of x plus cosine squared of x equals 1. We'll need that for number 4. So looking at number 4, I see I can factor out a 9. And then have a 1 minus cosine squared of x over 5x squared. So this is coming from here. If I manipulated this and subtracted cosine squared over, I would have 1 minus cosine squared. That leaves me with just this being sine squared. So I'll write 9 sine squared x over 5x squared. And then I want to take out the 9/5. And I'll have sine squared of x over x squared. And that can really be multiplied or split into multiplication of a limit as x approaches 0 of sine of x over x times another limit of sine of x over x. So really, that's still going to be 1, because if this identity was 1 squared, it's still 1. So that's 9/5 times a 1 times a 1 is 9/5. All right, number 5, we have not seen anything with tangent yet. Let's think about what we could turn tangent into that would have sine and cosine. Do you remember tangent is sine of x over cosine of x? So let's replace that. And then I see this in the numerator and this in the denominator. They can cancel out. Sorry, I'm going to quit writing limit for just a minute to save me some time. Negative 8 sine of x over 9x. And so I'm going to take out the negative 8/9, and then you see where I'm going, hopefully. And so this becomes 1, so it's negative 8/9 times 1, which is negative 8/9. We have one more. All right, this one is tricky. It's very tempting to take out the 7, and in fact, I tried it, and it did not get the right answer. So what you want to think of is back to, well, I've got 3 terms in the numerator all over this denominator, and I'm trying to get something with sine or cosine, and I'm seeing this could be a 1 minus cosine squared. So what I want to do is split that into a fraction and then plus this fraction. Because like I said, I tried it because I thought surely you could factor out a 7, and it didn't work. So I'm going to have 7 minus 7 cosine squared x over 4x squared plus 7x squared over 4x squared. Now you can take out a GCF. So take out a 7. And you have times 1 minus cosine squared over 4x squared. This, I'll leave it. I'll show you what's really happening. Okay, so we'll leave it for now. I'll bring the 7/4 in front, then I'll keep x squared over x squared, which is 1. So you could make it a 1. Okay, and then I see 1 minus cosine squared. That was that identity that came from here. That is really equal to sine squared x. So I'll have 7 sine squared x over 4x squared plus 7/4 limit as x approaches 0 if you want to make this 1. This is just that horizontal function at y equals 1, so no matter what the x value is, that's 1. And then here I want to take out the 7/4. And I have sine squared x over x squared. And remember, this is really sine of x over x times sine of x over x. Well, those are both 1, so this is going to be 1. And this is going to be 1. So I've got 7/4 times 1 plus 7/4 times 1. So 7/4 plus 7/4. Common denominator, they have it, so that would be what? 14/4, which reduces down to 7/2. So that is where the horizontal asymptote, or not horizontal asymptote, sorry, the limit as x approaches 0 would be.